Hi all, welcome to my YouTube channel Know About Embedded System. In today's video, I'm going to discuss you one important concept called as a DAC. You might be knowing already what is a DAC. DAC stands for Digital to Analog Converter, and where it is used. In most of the microcontrollers nowadays, this DAC is used to produce analog outputs. Best examples, I can give you audio and video output. So wherever you're getting audio and video output, definitely we're going to use DAC, that stands for Digital to Analog Converter. Let us explore today. If you are a new viewer to my channel, please subscribe my channel and gain the knowledge on embedded system. Come back to the video here. DAC, that stands for Digital to Analog Converter. What is the significance of this DAC? I'll give one simple use case. DAC is called as a Digital to Analog Converter. Best example, I'll give you audio and video output. Your mobile phones, your speakers, your digital watches which are producing different sounds. How it is possible? That is because of DAC. Because sound is in analog in nature. Video output will be in analog in nature. So how analog output is produced from the embedded system? That is possible from the DAC. So DAC, Digital to Analog Converter. What is the need of this DAC? So as I told you already, in embedded system, DACs plays very important role in our embedded system. Without DAC, again, it is not possible to produce your embedded system design. Okay, so what is an input to the DAC? The input to the DAC will be digital bits. Here you can see this is your input. Binary bits we will be giving. That is nothing but digital data we will give as an input to the DAC, and output from the DAC is analog output. It can be any form. Preferably, most of the time we're going for voltage and current. So most of the time output will be in the form of current and voltage. Any one form most of the time we will be considering. So DAC is, you can see here, DAC converts the binary bits into corresponding analog outputs like voltage and current. Okay, the best examples already I told you. We're going to use DAC in audio and video processing, headphones, speakers, and so on. Okay, and at the same, along with that, in order to produce a sufficient voltage to the motors, sometimes we wanted to control the motors. In that situation also we will use a DAC to produce a proper voltage and current ratings to control the motor, and also in order to control the temperature, in order to produce some activating outputs to the temperature and pressures, we will use a DAC, and also in order to control some of the display devices. So that means a DAC, without DAC, it is not possible to design any embedded system. So with this note, we will understand how DAC works. So as I told you already, DAC will take an input, digital input, then nothing but binary bits. It will produce an analog output. That's the basic thing. So this analog output will be in the form of voltage and current. And for this DAC, two important things required. One is a reference voltage and one is a ground voltage. Two important things required. So this block we will understand with the circuit diagram. So this is called as a R to 2R DAC, and one of the most important DAC which is used in most of the microcontrollers. If you take any microcontroller, preferably they're going to use R to 2R DAC. So this is a simplified circuit diagram of your DAC. This DAC will use resistor ladders to produce an output, to produce analog output. So here you will get analog output, and inputs to this circuit is a binary bits. Here you can see these are all the binary bits we're going to use. These are all binary bits, B0, B1, B2, and B3. These binary bits we're going to use as an inputs to the R to 2R ladder, nothing but DAC R to 2R ladder. This is a very voltage divider circuit. It's a voltage divider circuit. We are going to use op amp here, operational amplifier, to produce the necessary gain. Okay. So in this example, currently what you are seeing on the screen, we are going to use 4-bit DAC. We have 4 bits B0 to B3, and we're having a feedback resistance, and we're having one pair of resistors with R and 2R value. So what will be the output? Output will be in the form of voltage or current. Output from this we will get voltage or in the current form. And how do you calculate that voltage or current? So this is the formula. Currently what you are seeing on the screen, the output V out is equal to, so this is my formula. V out is equal to minus RF into reference, V reference divided by R into B naught 2 power n minus 1. It goes like that. So this is the equation to find out output or analog output voltage of your DAC. And I have considered one use case here. Let us calculate with one use case here. You can see one use case I'm considering. Let us keep RF is equal to 1 kilo ohm. This feedback resistance I'll keep it as 1 kilo, and R I'll keep as a 2 kilo ohm. RF is 1 kilo ohm and R I'll keep it as 2 kilo ohm, and I'll keep reference value as 5 volts, and I'll keep these binary values as 0, 0, 0. So these binary values, what you are seeing, these binary values I'll keep it as 0, 0, 0. And when you calculate output voltage for this combination, we're going to calculate. This is the second use case. When a second use case says like this, 1, 1, keep it all bits as 1, 1, 1 and calculate the output voltage using this equation. That will produce 4.68. Okay, in this way we can calculate output voltage manually, but in the microcontroller it is already designed, and you need to load input voltage, input bits, and automatically DAC will start converting its output. So this I'll explain you through the program later. So this is the background theory of your DAC. DAC, digital to analog converter, which will use ladder network, resistor ladder network. So here I'm using only 4-bit ladder. That means 4 bits I'm using, and I'll get this type of outputs. I have one more parameter with the DAC, that is called as a resolution. This is a very important thing in the DAC. DAC's resolution. What do you mean by resolution? This resolution stands for, it's the smallest voltage change or current change that DAC can produce. So this is also one of the important parameter for the DAC. DAC resolution refers to a smallest change in the analog output voltage or current is called as resolution. Okay, so with the example again I'll consider here. I have 2 use cases here. Let us take the example number 1 here. I'll consider 4-bit DAC, and in this 4-bit DAC, okay, before going to that, we have to understand the formula for this. Resolution for a DAC is equal to V reference divided by 2 power n. This is the equation to calculate the resolution of your DAC. So V reference is nothing but 5 volts, and n, let us keep it as 4. There are 2 use cases here, you can see. So I have considered one use case with a 5 volts and one use case with a n is equal to 4 and one use case with the n is equal to 10. So 2 use cases I have considered. Let us see the differences here. When you keep n is equal to 4, so when you keep n is equal to 4, so this is my DAC, and this is for n is equal to 4, and this is for n is equal to 10. So when you go for n is equal to 4, let us see the output voltage here, what you will get. When you go for n is equal to 4, use the formula, reference let us keep 5 volts, and n is equal to 4, that is nothing but 5 divided by 2 power. So I'll be getting like this, 5 volts divided by 2 power 4, nothing but 16, and you will get a resolution value as 0.3125 volts. That means with a 4-bit DAC, you can produce minimum voltage of 0.3125 volts. Okay, so this is the one use case. And second use case here you can see. Second use case, I'm keeping n is equal to 10. When I keep n is equal to 10, again the same procedure. Substitute n V reference as 5 and n is equal to 10, and when you calculate, you will get 4.8 millivolts. So just try to understand here. When you keep n is equal to 4, it is getting 0.321, and when you keep n is equal to 10, it is getting 4.8 millivolts. It is not a volt, it is a millivolt. So what is the conclusion here is, whenever you're going for DAC or ADC, you have to keep with a less resolution. That means the resolution value should be as minimum as possible, as less as possible. So how we can do that? When you increase number of bits, when you increase number of bits, resolution value automatically will get reduced. Okay, so that means minimum voltage the DAC can produce is 4.8 milli in case of 10 bit. So that is the reason in most of the microcontrollers, especially 32-bit microcontrollers, we use 10-bit DAC, 12-bit ADC, 12-bit ADCs, 12-bit DACs, and 12-bit DACs and 12-bit ADC we will use. Okay, to get a more resolution. So when you have more resolution, you will get a very clear output. Audio will be very clear, video will be very clear. Your current and voltage fluctuations will not be there at all. Right? So in this way, with the help of DAC, we can produce different analog outputs such as current, voltage, or some of the other parameters of our electronics to control the different motors. Okay, so like that we're going to use a DAC. So with this, I just want to close my today's video. I'll come up with the next video with the programming. Till then, keep on watching my channel, know about embedded system, and subscribe my channel.